Week 1, evaluating linear functions. So what we're going to be covering today is how to evaluate a function. A linear function. A linear function is usually specified numerically using a table of values, graphically using a graph, or algebraic using a formula. And so let's look at example number 1. So here they give us a table and they want us to evaluate f of 0. So the number in the parentheses represents the variable x. So in this case, x is equal to 0. So this is your x. So to evaluate this, we go to our x, we find our value 0, and you can see that the value for f of x is going to be 4. So when you're doing this, really what's going on is when x is 0, our y is going to be 4, but instead of y, we're calling it f of x. So it's another way to name y. So here our x is 2, so we look for 2, and our y value is going to be equal to 0.5. And then for this one here, we have f of 1, which is negative 1, minus f of negative 1, which is also 1, and that's going to be equal to negative 1 minus 1 is equal to negative 2. So let's try the next one. F of 1 is negative 1, and f of negative 2 is 3. So negative 1 times 3 is going to be equal to negative 3. Let's look at example 2. It says use the graph to find the approximate values. So f of negative 2, again, remember in the parentheses that represents the value of x. So we go to our graph, here's x. And if we go to negative 2, this is negative 2 right here. We want to see where it touches the graph. So if we go up, we can see that y is going to be equal to 1. So let's look at 0. So here's 0. If I go down, then I can see the y value here is equal to negative 2. Let's go to f of 2. So here's f of 2. So here's x equals 2. The y value is 0. And so f of 2 was 0 minus f of negative 2, which we figured out was 1. So 0 minus 1 is equal to negative 1. So let's try example 3. So here they give us an actual function, an equation. So remember that your x is what's in the parentheses. And so what we're going to do is anywhere we see a negative 1, we're going to replace it in for every x that we see. So here we would have 3 times negative 1 squared minus 2 times negative 1 plus 5. So we end up with 3 times negative 1 squared is 1. Negative 2 times negative 1 is positive 2. And then we have plus 5. So 3 times 1 is 3 plus 2 plus 5. So 3 plus 2 is 5 plus 5 is 10. Therefore, g of negative 1 is equal to 10. Let's go to the next one. So I'm going to write down the formula. So we have 3x squared minus 2x plus 5 is equal to g of x. So we want to find g of 4. So anywhere we see an x, we're going to substitute 4. So we have 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is going to be 256. So we get 3 times 256 minus 8 plus 5. And 256 times 3 is equal to 768 minus 8 plus 5. And so we subtract the 8 and add a 5, and we get 765. So g of 4 is equal to 765. Okay, let's try another one. So we have g of x is equal to 3x squared minus 2x plus 5. I always like to write down the problem, and then below it, I write down our question, g of x plus h. So anywhere we see an x, we're going to replace it with x plus h. Okay, and then we want to simplify. So x plus h squared can be written as x plus h times x plus h. I'm going to distribute the 2, so I get negative 2x minus 2h plus 5. I'm going to multiply these two, so we get x times x is x squared, x times h is xh, x times h is xh, and then we get an h squared minus 2x minus 2h plus 5. Distribute your 3, so we get 3x squared plus 3xh plus 3xh plus 3h squared minus 2x minus 2h plus 5. Gather your like terms, 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 5. So these were my common terms. So we say that g of x plus h is equal to all of this. Okay, let's try another example. So here we have f of x is equal to 3x plus 2. So anywhere I see a x, I'm going to replace it with a. So I get 3 times a plus 2 divided by 5. And 3 times a is 3a. And I cannot simplify any further since I don't have like terms. And then the last one here will be 3 times a plus 1 plus 2 divided by 5. We distribute the 3. So we get 3a plus 3 plus 2 divided by 5, which is 3a plus 5 divided by 5. So my answer here is f of a plus 1 is equal to 3a plus 5 divided by 5, or you can also write it as 3a divided by 5 plus 1. So either way would be fine.